Hello and welcome back to our next uh, maths lesson. And we're going to continue with subtraction of fractions and looking at mixed numbers. So those of you that need to go back over this, obviously we are going to. This time we're going to go through one, so through the whole number, just to explain how that would work. I talked about it in the previous lesson, so hopefully it's nothing new and we can just go back over it. So let's have a look. Quick recap, well, give him the first answer away. Can you have a go at these ones, please, for me? Pause now and have a go. Okay, let's go through the answers. So whole one is the same as 5/5. 4 whole ones are the same as how many thirds? Well, we do 4 times 3 as the denominator equals 12. So we have 12 as our numerator. That's the trick that gets us there. It should be fine. Then we've got 6.5. I'm assuming this is minus 5/12. So what we do first off, that should be minus, not there, is change that into 12ths. We times it both by 6, which has got 6/12. And then we can just do the sum because we've got enough numerators here to finish it. And the same here, we have to just change this 2 into fractions. So the easiest way to either we take 1 out, so 2 becomes 1 3/3, like that. Then we can take the 1/3 away and we have 1 2/3. All I've done is taken 1 whole out to make it 3/3. So we kind of split it into a part whole model and just put 1 there. This is still the same as 1, so 1 and 1 is 2, but we've just made 1 into 3/3. So we can do the subtraction. Okay, so I don't think it's possible to calculate 2 1/4 minus 5/12. But because when we do this, we don't have enough 12ths in order to subtract 5/12. Well, that's not entirely true, is it? Have a think. I've kind of given you a hint, but have a think. What do you think? Well, even if we do, sorry, I'll write it here, 5/12. We know that the 2, it can also be written in 12ths as well. And then we could take away 5/12. 1, 2, 3, 4, 5. We still have 1 whole one and 10/12 left. So that's a bar method way of doing it. And we can split it down like that to get our answer that way. What we could also do, and the way I would do it, is 2 3/12. If I didn't have enough, I can take 1 out of here, which would be 2/12. So I could put it as 1, 12 and 12/12. That's 1 plus that 3/12 on. So therefore I have 1 and 15/12. Then I can take away the 5 and I get to the same answer of 1 and 10/12. That would be my way of doing it. The bar model works perfectly. And you can also use a number line like this, look where 2 and 3/12 are, look at either the difference between them, which is that way, or you can go the other way as well if you like, going down. Here's 2 questions that do the same thing. Have a go, see what you think you can do. Pause now. Okay, so answers. We got 1 and we've times both of these 2 by 2 to get there using our equivalent fraction rules. So, but we don't have enough 12ths, so we have to break the 1. Yeah, we break the 1 up, the 1 becomes 10/12. So in total, we'd have 12/12. Or we do it that way and get 5/12. Or we go, okay, I have to break this down. That becomes then 10. I'll write it up here. 10 plus the 2, so that's 12/10 minus the 7/10, and that equals the 5/10. Bar model works fine, splitting up works fine, number line works fine. I just find this easier myself. I know that 1 is just whatever. I just need to take a whole 1 out. I don't need to take a complete whole 1 unless I only have 1. But I just know that 1 I can then add on to this, and I definitely have enough because I can cross that boundary. Same goes down here. So if I times both of these 2 by 3, I get 6/12. I don't have enough. So what I would do is I go, okay, in that case, let's take 1 whole 1 out. So I've got 1 whole 1 left. That's 1 whole 1's 9, plus the 2 is 11. Then I'm taking away the 6, and I can just do this how I normally would. I don't have to worry about the 1. 11 minus 6 is 5. And then we have our answer. Or again, use a number line and do the same thing and get the same answer. Personally, I do it my way, but either way works. Any of these methods that we talked about here will work perfectly fine for you. I think probably I'd say the bar model takes the longest, but probably is the most likely to get you to the correct answer because you can always get there. I think the one that's quickest is the abstract method, which is the way that I've used. I think the number line kind of comes partway between that, but I think the number line also can probably cause the most easy errors. So I'd just be wary of that if you're using it. So here's a couple more questions. Which calculation will break the whole and how do you know? Have a look. So we know because what we've got to do, we've got to times that by 2. We've only got 2 there, so that must break the whole. Whereas this one over here, we times this by 2. We've definitely got enough here not to have to break the whole. So in this case, take 1 out, which means we've got 14, plus the 2 is 16. Then we can take away the 6, which leaves us with 1 and 10/14, because 16 minus 6 is 10. And then this one over here, we can just do straight out. Nice and easy, like that. Here's some questions. Have a go. See what you can do. Pause now. Okay, so with this, the first one, it says use a bar model. And I think it's probably useful to do it just to check it out. But it looks like this. You, first off, obviously have to find out what half is in 12ths. So half is the same as 6/12. So we can put that there and fill in that. The same here, and we just minus them. 1/3 is in 12ths is 4/12. And then the same here is 3/12. And we just do the subtraction and count how many you've got left, how many whole ones and how many parts do we have left. Complete the subtraction up here. Again, all we have to do, is change that. So times that by 2, that one times by 2 as well. Like that. It's good, it's not working. Then we've got enough. This becomes 2/8. So we have none left, just got 3 left. This then we'd have to break the whole, or look, there's a little bit of a pattern going on here. This would also be the same as 6/8, which is fine. So you could, if you notice the pattern, just follow the pattern. At what point did you answer have to break the whole? And we have to break the whole at this point where we get beyond 3. And then it says tick the calculations that will break the whole. So the easiest way to do it is to work out whether or not you need more than you've got. So 2 times 5 is 10, so that's 5. We have to break it. This one here times this by 2, you got 6 and 8, so easily enough. Here times this by 4 to get to 12, so times that by 4, fine. And this one times by 3, and we just have to break the whole there. Then complete these subtractions. And these are all about breaking the whole, you can see. So times it by 3 and we get 15. Times that by 3, we got 3. Well, we kind of have to take one out. So we take a whole one out, which is an extra 15, plus the 3 that we already have is 17. We can then minus the 7. 15 and 3, sorry, 18. Then we can minus the 7 and get that. This way we have to make sure we've got this in terms of 16ths first. So we times it by 2 is 10. We don't have enough. So again, we break the whole, take one whole out, that becomes 16 16ths, plus the 1 is 17 16ths. Then we can do our subtraction and we get the answer here. And then you can see, continue on to get the answers very similarly in the rest of them. Okay, so Dexter watches television for 3 hours and 2/5 during the weekend. Dora watches for 13/15 fewer hours than Dexter. Dora watches an hour of television on Saturday. So for how long does Dora watch television on a Sunday? So this is quite a long-winded question and it involves lots of bits and pieces. So we know Dexter watches for 3 hours and 2/5, and we know Dora is less than that by 13/15. So in order to find that, what do we have to do? Well, we have to do a subtraction. So we do 3 and 2/5 minus 13/15. That will get us what Dora has in her, how much she's actually watched. So in order to do that, we've got to times this here by 3 to get to 15. So that's 15 and times the top by 3 is 6. We're taking away 13/15. So what we're going to have to do is break the whole. So we take a whole one out of here. That goes down to 2. A whole one is the same as 15/15. So we can add 15 to here, make it 21. And then we can do our subtraction, minus 13. So minus 10 is 11, minus 3 is 8. So it'd be 2 and 8/15. There you go. See, got to the same answer finally. So that means Dora now is 2 and 8/15. There you go. And then it says she watches an hour of television on Saturday. So we can take an hour out, which is nice and easy because we're just dealing here with the whole numbers. Look. So 2 minus 1 is 1. 1 and 8/15 she watches on Sunday. There you go. The difference between a fraction and a mixed number is 3/4. The fraction has a denominator of 12ths. What could the fraction and mixed number be? So here's a rough idea of what you're doing. You're doing, this is your mixed number. This is the fraction that you're minusing 3/4 from. It's got a denominator of 12. So we know that both the mixed number, to make it easy, and the unknown number denominator of 12. So what we need to do is also put 3/4 in terms of 12, which we've done here. So it doesn't say anything about needing to worry about what the whole number is. So what you can do, as long as you're thinking about breaking the whole, it can be lots of different ones. But as long as you're thinking of breaking the whole, what you need to do is take away 9, be able to take away 9/12. So you need a whole number to take away whatever you put here, you then can take away 9 to get whatever you've got here. There's lots and lots of answers. So it could be lots of different answers. You wouldn't just be one. If I could have 2 and 6, and that would give me a different answer, but it would still be perfectly valid. So here's some questions for you. Have a go. See what you can do. Pause now. Okay, let's go through the answers. So first off, question 4 says, here are some ingredients. We've got potatoes, 2.5 kilograms. We've got cheese, 7/10 kilogram, and carrots, 1 2/5. It says, how many more do the carrots weigh than the cheese? So we take the carrots and we take away the cheese. And we see what that equals. Well, in the first thing we have to do is times this by 2 to get it in tenths. So we times the top by 2. We don't have enough, so we break the 1 and add 10 to our numerator, because that's what the denominator is. Then we can do 14 minus 7, which is 7/10. Then it says Jack uses 17/20 of carrots. How many kilograms of carrots will he have left? Well, we take our carrot weight and we take away 17/20. First step, as normal, is we times this by 4 to get to 20. So you have to times the top by 4 as well. We don't have enough, so we break the whole. One whole is the same as 20/20, so we add 20 onto here. We got 28/20 minus our 17 is 11/20. Then it says Jack uses all of the cheese and the same amount of potatoes. How much do we have left over? So Jack uses all of the cheese and the same amount of potatoes. How much do the leftover potatoes weigh? Well, we take all of the potatoes and he's using the same amount of potatoes as he has cheese. So 7/10 worths. How much he has left? First off, put this in terms of tenths. So that's timesing by 5. That's timesing by 5. We don't have enough. We break the whole. One whole is the same as 10 tenths. So we add 10 onto 5 and get 15. And then we get 1 8/10, which is the same as 1 4/5. Over this side. We've got Ava is doing a long jump. On her first attempt, she jumps 3 meters, 3 2/9 of a meter. And her second attempt is 2/3 of a meter shorter than her first. How far did she jump on her second attempt? Straightforward subtraction. So we have 2 3/9. We're taking away 2/3. Then we have to work out. So we've got to times this by 3. So times the bottom by 3 and times the top by 3. So we've got 9ths on the bottom. We don't have enough here, so we break the whole. And we have to add 9 to the top because that's what the whole gives us. That gives us 11. 11 minus 6 is 5. And we still have that 2. So 2/5. 2 5/9. Question 6. The difference between a mixed number and a fraction is 7/8. The fraction has a denominator of 16. What could the mixed number be? So the mixed number is something over. I love it when it does that. Something over something, but it's going to have 16 on the bottom. The difference is 7/8. So what we take away is 7/8, and we've got something over something, with the denominator being 16. Probably a mixed number, or could be a mixed number anyway, so we'll leave space. And then we just have to fill in these blanks. There could be something here. Put this in terms of 16th first. So times it by 2 and times it by 2. So 14 over 16. And then we just need something on the top. So if we had 1 as a whole number and 1 as the 16th, so that then would change to be 16 plus that is 17, and we'd have 3 left. So that's our answer there. And then you could change it so you had 1 here and 2 here. And then you add 16, that's 18, minus 14 will be 4/16, and so on and so on. And there are thousands of combinations, but as long as you get the idea right, then you'll come up with some. That's all for today's lesson. I hope that made sense, a little bit more practice. And I hope you found a way that works for you. Remember, you've got a couple of different ways. You can do the short abstract method. You can do the splitting of the part whole and doing it as a diagram using a bar model, or you could do it as a line along a number line. Whatever works for you, use that one. Good luck, and I'll see you in the next lesson. Goodbye.